Hello, everyone. My name is Charlie Copeland, and this is Unit 6 assignment on network graphs. This presentation covers the cybersecurity analysis of Network 2 and Network 3 using Tableau's dashboard you will see here on the next slide. Both networks contain the same number of employees, and the goal is to evaluate how fragile or robust each network is based on their structure. Here on this dashboard on the left-hand side is network 2. This network shows a dense web-like structure with many overlapping lines with multiple communication paths connecting each employee. The nodes vary in size and color based on their betweenness, which indicates how central a user is to flow of the information, as you can see. We have the light blue nodes here and the dark blue nodes as well here. In network 2 as well, the betweenness values are spread across several nodes. No single person dominates the communication, and there are multiple alternate routes between most of the nodes, as you can see. Because of this structure, network 2 is more robust. If one person becomes infected with the malware, the network still stays connected because messages can reroute through other paths. Li- Likewise, if one person's device goes offline, the company will still be able to communicate through other nodes. My recommendation for this client is to continue monitoring the more connected nodes, but overall, network 2 is stable and resilient. Here on the right on this dashboard, we have network 3. This network looks completely different from network 2, as you can see. The network, instead of the dense webbed chains, network 3 forms a long chain or a backbone with very few cross connectors. Almost all communication flows through a small cluster or a central node, as you can see here. You can clearly see this in the visualization because a few middle nodes appear in much larger and darker here. The nodes act as choke points for the entire system. Because the network depends heavily on just few central users, network 3 is much more fragile than network 2 is. If one of these middle nodes become infected with malware, I'm sorry, if one of these nodes become infected with malware, the infection spreads rapidly through both directions of the chain, as you can see. It goes vertical and horizontal here. And if the central node goes offline, the entire network splits into disconnected sections and all communication fails. My recommendation for this client is to increase redundancy by adding more cross connections so information does not rely on a small number of critical users. When comparing both of the networks side by side in the dashboard, the differences are very clear. Network 2 is highly interconnected and resilient. It has multiple communication paths distributed between this and no single point of failure. Whereas Network 3 is long and fragile, chain with a few major bottlenecks. If one central node is compromised or goes offline, the entire network breaks apart. For these reasons, Network 3 represents the higher cybersecurity risk. Improving redundancy and reducing dependency on central nodes would significantly improve its stability. Thank you for watching this presentation.